Let's multiply more polynomials because it's so fun. In the previous video, we sort of started this process out with smaller multiplications and they got a little bit bigger and maybe a little bit bigger. And so here we're, having let that percolate for a day, we're going to dive back in and just sort of look at them generally and figure out what to do in any cases. Now, the ones that you see on the screen are the ones I'm going to do for you. And then there will be some that you can try for yourself. And then there will be the usual extra worksheet as well that's up there in Google Classroom. So I want to have you ready that you can tackle all the problems on that worksheet. So if you remember what yesterday's looked like, these look a little worse, but only because there's more terms. It's still one polynomial times another polynomial. And if you remember the basic idea, you've got it under control. In fact, these instructions say multiply these using the box method or the vertical method. Honestly, I don't know what those are. And I don't know that we need to know what they are because we know how to get these done anyway, just by remembering that multiplication is distributive. And so say that first one, x plus 2 times x squared minus 5x plus 4, in order to get that done, we just have to remember that everything in the x plus 2 has to multiply everything in the parentheses on the right. So that means when we do this multiplication out, the x is going to come over here and grab 1, 2, 3 products. The 2 is going to come over and grab 1, 2, 3 products. We're going to end up with 6 little tiny terms, and we're going to add together the ones that we can and leave alone the ones that we can't, and then we're done with it. Okay, so it's the same routine as before. Now you're all fresh from yesterday, so this should be no problem. So I'm going to grab my x and I'm going to let it multiply everything in the parentheses on the right. So I will get, first of all, the x times the x squared will give me an x cubed. And then I'll grab the x, multiply by the minus 5x. Watch that minus sign. That will give me minus 5x squared. And then this x times this 4, that'll give me a plus 4x. And now I'm going to grab this 2, and I'm going to multiply it by the x squared, the minus 5x, and the 4. So here comes 3 more terms. I'm going to hit return and put them on a new line, but it's still all the same expression. There's a plus 2x squared from the first 2. Now this 2 times the negative 5x, that'll be a negative 10x. And this 2 times this 4, even on a bad day, I know that's 8. So there are our 6 terms, and now we're just going to look to gather the terms that we can gather because they look alike and can be added together. Our little friend x cubed here, we'd have to see other x cubes in order to combine that. We don't see anymore, so he's all alone. Then we have this negative 5x squared, but oh, look there is a partner 2x squared. So negative 5x squared plus 2x squared, now we're up to a negative 3x squared. Similarly, this 4x, he has a buddy. He's got to add to the negative 10x, so 4x minus 10x, negative 6x. And this poor lonely 8 has nothing to add to, so we get 8. And now we've taken that product, we've reduced it by combining like terms, and we are done with it. That's it. This is more organization than it is anything else. Okay, so here's the next one. Think ahead. How many individual terms are we going to generate when we're done with this product? Well, just like the last problem, we're going to generate 6. How many of them will we get to add together to shrink it down a little bit? Well, we'll see. So step number 1, grab onto this 3x and let her, let's be fair, multiply all of those. So the 3x times the negative 2x cubed, well, the negative 3 times the negative 2 is negative 6, and x times x cubed is x to the 4th. Okay, so that product is taken care of. This 3x times that 5x in the middle of the second one, that's going to be a 15x squared. And this 3x times negative 6, that'll be a minus 18x. Okay, and here we have to be careful. It's not harder. We just have to be careful. The next product, we're going to take this minus 4 and multiply it by minus 2x cubed plus 5x and minus 6. So we got to observe the minus signs properly. So the negative 4 times the negative 2x cubed will give us a positive 8 from the negative 4 times negative 2, and there's still just that x cubed sitting there. And then this negative 4 times the positive 5x will get me negative 20x, and this negative 4 times this negative 6 makes a plus 24. Okay, so we generated 6 terms altogether, and now let's find the ones that we can mush together because they have similar powers of x. Well, again, the negative 6x to the 4th is a lonely gal. She doesn't get to combine with anything. Let's go hunt through the powers of x in decreasing order. So we've used up that one. Let's go look for our x cubes. Are there any? Yeah. So right here, there's only one. So there's a plus 8x cubed. That's all good. Let's go look for our x squareds. Well, there's only this one. So plus 15x, and then, oh, looky here. Now we get to actually add some things together. This negative 18x and this negative 20x. So there's negative 18x's, and we're going to remove 20 more x's. We are down to negative, whoops, I forgot a squared there. Negative 38x, and that lonely 24. Okay, so this time we didn't really get to shrink the original distribution of multiplication. It generated 6 terms. We got to add 2 of them together to shrink it to 5. We are left with this mess. It's a 4th order polynomial, 4th degree, because here is the leading term. Remember that. The power of the leading term is 4. That makes the degree of this polynomial 4. And we could have identified that from the very beginning, right? Just looking at this, we know that by the time we're done with all the multiplications all the way across, the highest power of x we would see is x to the 4th. So we could have predicted polynomial of degree 4 as the result before we even started. How many terms it would end up having? There you gotta see how the multiplication plays out. But again, remember, this is more a battle of organization than it is difficulty. Okay. And then this one. Okay, this looks a little bit weird because it's presented in a compact form. What we have to do is recognize, so how do we multiply this out? Well, we have to see it in action. So I'll just leave it in blue. Before we start worrying about the multiplication, let's see what we're looking at. Right? X minus 2 cubed is x minus 2 times x minus 2 times x minus 2. So we have like a triple multiplication. Instead of going through and cherry picking all the products, let's do this one step at a time. So first, let's just multiply those two together. So this product, its next step is, now I'm going to do this a little bit quicker. Okay, I'm looking at these two right here. So first x, we're going to FOIL this. First, outer, inner, last. So this first x times that first x, there's an x squared. Okay, here's where I'm going to speed things up a bit. This x times that negative 2 is a negative 2x. But then also we will find this product from the inner terms, which is another negative 2x. So we'll have a negative 4x altogether. And then, careful with negatives, this negative 2 times this negative 2 makes a plus 4. Okay, so that's the first two of those multiplied, and now the x minus 2 trailing still needs to be multiplied through. This is in a slightly different order as the ones before, but it doesn't matter. We just have to remember that all the terms in the first blob have to multiply with all the terms in the second blob. So we're still going to generate 6 terms out of this. How's it going to happen? Well, this leading x squared times that x, there's an x cubed. This leading x squared times that minus 2, there's a negative 2x squared. Now we're done with the x squared. This negative 4x in the middle times that x, well, there's a negative 4x squared. And this negative 4x times this negative 2 makes a plus 8x. We're done with the negative 4x. And now this 4 times this x, there's a plus 4x, and that 4 times that minus 2 is a minus 8, and now we're done with the whole thing. All 3 of these have each multiplied the x and the negative 2 to lead to this expanded thing, And now we just have to go collect like terms. And actually this will shrink down kind of nicely. So the x squared, the x cubed is leading, and there's nothing to combine it with. How about these two terms together? Those are like terms. Altogether there's minus 6x squared. And then how about, these two terms together? There's an 8x and a 4x. There's a plus 12x, and that leaves that lonely minus 8, bringing up the end. And there we go. That is the result of, this. Where'd my red dot go? There it is, kind of. That right there is the result of x minus 2 cubed. So this one's an example of, what turns out to be a longish multiplication from a pretty benign looking starting point. All right. By the way, don't do this. X minus 2 cubed. Well, x cubed would be x cubed. Negative 2 cubed would be minus 8. So ta-da, there's the answer. That is wrong, right? There's all that distribution that has to go in place, and we see that when we open up the x minus 2 cubed into x minus 2 times x minus 2 times x minus 2. And now we see all the distribution that's going to take place, leading to 3 instances of 2 terms apiece, so that's 6 terms altogether, which collapse to 4. And I think there's one more. Yeah. This one's actually no different than one of the first ones, but it was on the page, so why not do it? Let's see if we can do this pretty quickly. I'm going to grab this 2x and send it through all 3 of those terms. That will give me 2x cubed minus 12x squared plus 10x. So the 2x is done. Now I'm going to take this 3 and I'm going to send it through all of those terms. So we'll have a plus 3x squared, a minus 18x, and a plus 15. There are the 6 original terms from this multiplication. Let's see what we can collapse together. These are kind of lined up already, right? That's probably what the box or the vertical method does, is it has you line up all the powers of x as you discover them so that you can add them up just vertically, but we can just fish through the line and grab them, right? We don't need to over describe what it is we're doing with buzzwords. So this negative 12x squared will add to this 3x squared, negative 12 of them plus 3 of them. That's going to bring it up to negative 9 of them. Here's your positive 10x minus 18x, so we're down to negative 8x altogether, and that lonely 15, just like the other constants, there's nothing they do but hang out. And so there you go. That's the result of that blue product up at the top. Okay, so this is multiplication of polynomials. We can click over to the next screen, or whoever is pushing buttons for you can click over to the next screen on this. They can open up this PowerPoint. It's there in Google Classroom. Go to the last slide, and you give these things a try. So just as an upfront diagnosis, if we look at this product on the left, we're going to generate 6 terms. The resulting polynomial will have degree 3, because after we're done with all the cross products in here, then the highest power of x that will occur is 3. From the leading x times that second leading x squared. And similarly, the one on the right, you're going to generate 6 terms. The leading term will be an x to the 3rd. So both of these will generate polynomials of degree 3. Okay. Just one side note, is sort of a heads up, is what we'll end up doing later. So let me go back to the, where was that first one that I did today? This one right here. What if you wanted to graph one of these polynomials? I mean, you'd have to, maybe you multiply it out first, get a 3rd degree polynomial like we did here, and you want to see what its graph looks like. How might you do that? Okay, well, one of the best ways to do graphs of polynomials, and this is bonus time now, right? This will come at you in a few days. I'm just giving you a heads up. Is to see how many times it has to cross the x-axis, because then you can plot those points, and then now you have thumbtacks in your graph that the graph of the polynomial is going to have to go through. This polynomial, x plus 2 times what is currently x squared minus 5x plus 4. You might remember that you could factor this to x minus 1 times x minus 4. So this left-hand polynomial factored down looks like this. Okay, and now if this is our function, we can see that there are 3 x values that will turn this into 0. X equals 1 from this middle piece, right? Negative 2 from this piece. These are the numbers that will make the function 0. And if we put a 0 in this spot by putting in x equals 4, the whole function will become 0. So these are the 3 x values where this graph of this third degree polynomial has to cross the y-axis. These are roots of the function. And so we already know, 1, 2, 3, 4, we already know 3 points on the graph of this polynomial. And so really the only question left is, does the polynomial swing down from above and do this and go through those 3 points, or does it swing up from below and go through those 3 points? And that's basically the only decision left to get a really good picture of what this polynomial looks like. So that's the kind of game we're going to be playing later on, is starting with a polynomial and discovering its roots. This one was pretty straightforward because we could factor it. If it's not straightforward, then there is one other thing we have to learn how to do to polynomials to discover their roots, and that's the opposite of multiplication, and that's division, and that's what's coming up next for you guys. Sorry. Oh, by the way, when you're done trying any of these out, go back to Google Classroom. There is that blank worksheet that has multiple, page 2 of the multiplication of polynomial worksheets. You should have done page 1 yesterday, but page 2 will have more like this, and you get to practice lots, and it's good for you, trust me. I'm a doctor.